Hello guys, Raymond is back here again in this channel, and so now today we will move forward. So just now we should look upon some other things. So this is the third page. So now from here we will look upon the equality of matrices. So now till we have studied about the types of matrices, and so what are the elements and what are the types, like as a scalar, diagonal, upper triangular, lower triangular, and so now we will look upon the equality of matrices. So here this says that two matrices A is equal to Aij M cross N and B, that is Bij R cross S, are said to be equal if both have equal number of rows. Okay. And there is some another condition that have both have equal number of columns. So actually this condition says that these two conditions says that if two matrices having similar number of rows and the number of columns, then these two matrices will be said to be equal. Like as here two matrices A and B. So if the number of rows in A, that is I, and the number, sorry, not I, that is M, and if the number of rows of what hmm, B are equal, and then the number of columns of A and number of columns of B are equal, then we can say that these two matrices are similar. And so if these two matrices will be similar, then we will say that this Aij will be equals to Bij. That means A is the element of ith row and jth column, and this element is equals to this element, and so this element belongs to the ith rows and jth column of the matrix B. So when these two matrices will be equal, then these two elements will be same. Okay. So now here I will be equals to 1 2 and goes to M, and J will be equals to 1 2 and goes to N. Okay, so this is just I and J just represents the ith rows and jth column. Okay, so if there is Aij, then this means that A is the element of ith row and jth column. Okay, so now move next point. So here is the sum of matrices. That means what is the addition of two matrices. So it says that two matrices are said to be conformable for addition when they have same number of rows or columns. This means that we cannot add two matrices. Okay, because two matrices are not, sorry, matrices are not as real numbers or such types of numerals that we can add simply. Okay, so if we have to add two matrices, then they should be conformable for addition. uh, how we should know that matrices are conformable for addition? So for these we will look forward. Actually here this says that two matrices are said to be conformable for addition when they have same number of rows or columns. So this condition says that if two matrices have same number of rows and same number of columns, then we can say that these two matrices are said to be conformable for addition. Okay, and so for example, let A will be Aij and B will be Bij, then A plus B. When we add these two matrices, then what will happen here? Aij plus Bij. That means that is mathematically we can define this addition of matrices as uh, just uh, uh, just the matrices should be of same order. Okay, because if the matrices are of a square matrix, or if M cross N, then the other matrix should also be the order of M cross N, or should be the similar order. Okay, so if A is M cross N matrix, then B should also be M cross N matrix. Then we can say that these two matrices will be conformable for addition. Okay, and then the addition of these two matrices uh, will be written as just we can do just one thing. We can add just the hmm, the corresponding elements of these two matrices will be added simultaneously, like as a11 plus b11, a12 plus b12. So the corresponding elements of both matrices will be added together. Okay, so just aij plus bij, that means if the I is the I a is the ith a is the element of ith row and jth column, so b will also be the element of ith row and jth column. So just we have to do one thing, we have to add just the corresponding elements. Okay, a11 will be added to b11, a12 will be added to b12, a21 will be added to b21. So just to add the corresponding elements. Okay, now move next. This next point says that the a plus b will be of same order of a and b. So this says that when we add the two matrices a and b, then the resultant matrix will be a plus b, and this resultant matrix a plus b will be of the same order, that of equal to the matrix A and of matrix B. Suppose matrix A is of order m cross n and B is also of the order m cross n, then this is the condition, and then these two matrices will be conformable for addition, and then then the sum of these two matrices, that is the A plus B, the matrix A plus B will also be the order of m cross n. Now we should look upon the difference of matrices. So its definition says that the difference of two matrices is equivalent to sum of A and minus B. So what is this? Actually, difference is just the addition of one positive number and one negative number. So here it is also similar. So here is just the difference of two matrices is equivalent to the sum of two matrices, like as first is matrix A and second is also matrix B. But here is something different, that in difference there is we should take the negative of B. Okay, so first is matrix A and second is matrix P but with a minus sign. Okay, so this is negative of B, so we have to multiply minus 1 with the B matrix and then we have to add with A. So this is mathematically defined as the sum of A and minus B. So now look forward. Yeah, look here. That is, if A and B are of same order m cross n, then A minus B will be A plus minus B. So just look here. A minus B will be equals to A plus minus B. That is the sum of matrix A and negative of matrix B. So just it got clear. Now move to the next point. This is a scalar multiplication. So what about the scalar multiplication? So the product of a m cross n matrix A and a scalar quantity K is a m cross n matrix whose every element is the product of the corresponding element of matrix A and a scalar quantity. It is denoted by K into A or A into K. So just actually this is not so much difficult. Let's try to understand this. This says that the product of a m cross n matrix A, uh, look here one thing. Here we have to do a scalar multiplication. A scalar multiplication means we have to multiply one matrix with a scalar number, with a scalar quantity. So what about the scalar quantity? The scalar quantity is just a number, or it means just a constant or anything else. Okay, so we can took this constant as k, so k will be the scalar quantity here. Okay, and k will have any type of value. K will be equals to 1 2 3 4 0, anything other else. So k will be our scalar quantity. Okay, and so the scalar multiplication means that the multiplication of k with the matrix A. Okay, so just this. So the product of a m cross n matrix A and a scalar quantity k is a m cross n matrix whose every element is the product of the corresponding element of matrix A and a scalar quantity. It is denoted by k into A or A into K. So when we multiply, then the product will be denoted by this. So this is the denotation for the scalar multiplication of k and the matrix. So k is the scalar quantity and a is the matrix. A is our matrix. So k into a or a into k, so both are similar, both are equivalent. So the scalar multiplication will be denoted as this. And so actually, what about the product, what in which form the product will be obtained? So look here. Actually, if you got any problem or any query or any misunderstanding, then please look here. Here is an illustration, an example, so you will got this concept very clearer. So here, look here. This is the k is the scalar quantity, and this is the matrix A. Okay, so when we multiplied these, then just don't do anything. This k will be multiplied by 1, then 2, then 3, then 4, then 5, then 6, then 7, 8, 9, and so its resultant will be formed as a matrix whose elements are just k, 2k, 3k, 4k, 7k, 6k, 7k, 8k, 9k. Just nothing. K will be multiplied with these all elements. Okay, so this is the k into a. This is the scalar multiplication of k and a. Okay, so now if you have any more doubt on this topic, then you can message me on my WhatsApp or my Telegram. Okay, so my WhatsApp and Telegram number is given in the description, so you can check there, and if you have any query, then you can message me. Now there are algebraic laws. So there are some algebraic laws that will be proved very useful for you when you should solve these questions. So we should look upon these laws one by one. So the first is the commutative law for addition. So what about the commutative law? So when we are studying when we were studying about the real numbers, the complex numbers, and integers, then we had studied these laws, the commutative laws and the associative laws. So just they are similar here. Okay, so that's nothing different here. That's laws are here too. So look here. If a and b are conformal or conformable, the same thing. So if a and b are conformable for addition, then a plus b will be b plus a, and this will be this. So this line says that the commutative law for addition says that if a and b are conformable for addition, means that what? This line means that a and b are of same order. Okay, they are of same order. So if a and b are of same order or conformable for addition, then we can write a plus b will be b plus a. That means we can change the order of these terms. And so also in this sequence, we can also do this thing. So minus b will become a. So the commutative law for addition says to change the order of the terms, in a given relation or in a given something, anything. This is a relation, so we can, according to this commutative law, we can change its order. Just then, now the next is the associative law of addition. So what about this? So this says that if a, b, c are conformable for addition, then this. So here it says that there are three given matrices a, b, and c, and so all three have the same order. And so here what it have written, here is a plus b is in the bracket and c is individual, and here is b plus c in the bracket and a is individual. So we can write this. Okay, so now move forward. So there is additive identity. So what about the additive identity? So the additive identity is just a number. So additive identity is just a number, and this number is such as when we add something. When we add anything to this additive identity, we just got that number. So actually, we have to understand this thing in this manner, that suppose that a is a number, or a is a matrix. Here it is this is the chapter of matrix, so we should consider this as matrix. So a is a matrix, so we have to find the additive identity. So this means that what we have to add with this a, then the result will be the itself A. So what should be added here? And so we can get here A. So 0 is only the number, 0 is only the thing that we can add with A, and we should get this itself. So 0 will be the additive identity for this matrix A. So from here we can add another line that 0 will be the additive identity for any given matrix, whether the matrix will be a square matrix or a rectangular matrix or upper triangular matrix or a lower triangular matrix, any, doesn't matter. 0 will be the additive identity for any other matrix. Okay, so these all are the things. Now we will look on the next page. So just this, so wait for some time. Actually the picture will become clearer. Yeah, so now, yeah, come here. These are some other things, some other theorems on matrices. So this read it: peculiarities of the product of matrices.